It's fantastic to be back in Abu Dhabi and to be at, this is now my third UMEX conference, and continues to be an incredibly impressive event and one that I'm delighted to be a part of. I'd like to start our panel today just by introducing the distinguished panelists that we have participating. I'd like to start with Air Commodore Alex Hicks, who's the Assistant Chief of Staff for Intelligence, Surveillance, and Reconnaissance in the UK Royal Air Force. Air Commodore Hicks joined the Royal Air Force in 1988, and following a 3-year apprenticeship served on the Tornado F-3 Force. He attended the Royal Military College of Science from 1996 to 1999, where he read electrical engineering, following which he was commissioned in 2000. He is currently employed as the Senior Responsible Owner for Protector MQ-9B, E-7 Wedgetail, and P-8 Poseidon aircraft. Thank you, Air Commodore Hicks. Next, I'd like to introduce Dr. Cesar Battaglia, who is a partner with PwC and leads the A&D practice in Italy. He has over 20 years of experience in A&D, big corporation at sea level. He has run multiple engagements in unmanned systems and technologies and supports the Italian institutional entities to write and publish the National Strategic Plan for Advanced Air Mobility. Dr. Battaglia, please join us on stage. Next, I'd like to welcome Emeric Moulin de Torsay, Operational Marketing Drones and Cyber with Naval Group. Mr. de Torsay is a retired Navy captain. He started his career in the French Navy in 1992 as a helicopter pilot. He has been with the Naval Group since 2020, and he ended his career in the French Navy HQ in the Atlantic. Please. Our fourth panelist is Petar Bedouar. He's the Chief Technology Officer for Saab AB. He started his career in 1992 as a systems engineer involved in the design of the first generation EW system for the Gripen aircraft. Since then, he has worked in several leading positions in operations, product management, strategy, and marketing with Saab electronics warfare and radar operations. Petar, please join us on stage. Great. So, well, thank you, gentlemen, for all being here. I'm looking forward to this panel. I think just from listening to the excellent first panel and from Mr. Alexander's speech, we see how important human-machine teaming and the concept of trust are to the future of military operations and to security and law enforcement as well. It's a pretty big topic, actually, as you probably already noticed. We've talked a lot about having trust in the performance of the aircraft, being able to validate and test that performance. But we also, in this panel, hope to get into some of the new operational concepts, sort of the ideas behind things like loyal wingman concepts or mosaic warfare, where one or small group of crewed platforms or human operators are in charge of a great number of uncrewed systems. So I think we'll talk about those concepts, and we'll also get into some of the challenges and opportunities associated with integration. But first, given the size and scope of this topic, I just wanted to go down the panel here and offer each of our panelists an opportunity to give their kind of high-level perspectives and perceptions of this topic, why it's important, and where it's headed. We'll start here.
Great, thank you, and thank you very much for this opportunity. I am an ex-regulator in the UK Military Aviation Authority, and why do I mention that? I mention that because I think it's very much driving how we're taking human-machine interfacing. I see the development of the ground station, the cockpit, that looks identical almost to an aircraft cockpit, to enable the regulator to take forwards the technology and accept it. I think there's a real nervousness in the Civil Aviation Authority, certainly in the UK, and within the Military Aviation Authority, about remotely piloted air systems. And I think we need to think carefully about how do we build that trust sufficiently with the equipment to enable those organizations to allow the flying in the UK. I think on Protector, the MQ-9 Bravo, we started off with Reaper in the Air Force as our medium altitude, long endurance aircraft. And we found some problems with the human-machine interface, and we spent a lot of time working with General Atomics to really optimize how that might look moving forwards. And the MQ-9 Bravo comes with a highly accomplished ground station. My concern is when we move to the multi-mission capability and start operating 3, 4, 5, 6 aircraft from a single ground station, how that might work. How will we get the regulator to accept this new world? We've no longer got a single pilot operating a single aircraft. It will be a single pilot, maybe through a laptop, operating multiple aircraft. So that human-man interface is going to change considerably as we transition to trying to operate multiple aircraft. And I guess the final bit, as the Air Force transitions to try and achieve net zero, we've got to really think about how do we optimize the training solution in the synthetic environment. I think we'll be looking at an 80% synthetic solution as we introduce the MQ-9 Bravo into service, but I will certainly, as an engineer looking into this world, be pushing them to take that to as close to 100% synthetic training as possible.
Great, thank you.
Yeah, my turn.
Yeah, your turn.
So I'll take back to some of the key points that His Excellency touched today about the boundaries that are no longer existing among civil and military worlds, and also what Alex was saying that in UK the civil aviation authorities basically is supporting and adopting the tech is demonstrating that these boundaries is no longer, generally speaking, in place. Today, I would like to share with you kind of point of view on how the unmanned technologies, intelligence, and human-to-machine interaction are determining a change of paradigm and approach towards leading aerospace and defense programs, and without limiting implication to only operational tactical environment. This is just because, as I said, as Tate was introducing me, I spent 18 years of my first part of career in aerospace and defense, big corporations, so I was part of the industry, so just joining consulting firm since some years. So I would like to switch the two heads from one to each other to give you two different but then converging points of view. So at the time of Finmeccanica, nowadays Leonardo, we were developing the first small UAV regulations to be used in airspace with no limitation, together with the General Retired Alessio Grasso. And this was a kind of partnership among aerospace and defense industries and regulator that was acting together as open system in innovating and then bringing towards the civil national authorities in adopting that. And the second one basically is much more nowadays in a real open working group with institutional stakeholder, aerospace and defense player, research, startup, and we will see later on maybe Tate also IT players in having a team up among unmanned technologies, AI, and human, let me say, machine teaming, in developing what we call the Advanced Air Mobility Strategic National Plan. So just touch on that for beginning.
Great, thank you. Emmerich.
Thank you, Tate. Indeed, we share that the revolution is more in the autonomous decision-making process aspect than unmanned aspect process, because there is a discontinuity here. And but this revolution makes all the more important the principles that still remains. For instance, the strategic principles, the warfare principles remains all the more true and must be respected for unmanned system to be relevant. And this is also true for team building. Team and trust are the two faces of the same coin, because team is the place where you build trust, and trust is the cement of the team. So when we want to build trust and man-machine teaming in unmanned system, especially for naval group, the underwater unmanned system, because there is this discontinuity, especially in communication and the control, which is not always there. And this environment shapes the need very deeply. And so we must assure that we respect the team building principles, and I'll state three of them. The first one is to know each other. Man must know the machine, and the machine must have the habit to work with the man. And this is where regulation and the building of the explanation of the algorithm is very important. And the French state puts forward the explainability of the algorithms. And so the qualification process has to be built together with the regulator. The second one is train together and train as you fight. And this is why the research and development must be conducted with the French Navy or with the end users for our perspective. And this is what we are careful to do. And in the end, we have to do missions together. And this is also very important, and we think that it will be, it not has to, but it will de facto be progressive from simple missions to complex missions to, once again, get used to one another. And this will be true at the three operational levels that we all know: the strategic level for the commander-in-chief and the HQ to trust at the end the unmanned systems. It will be also true at the tactical level for the commanding officer of units working with unmanned system to trust them. So it is very important to respect principles to our perspective, because this principle will still be true through ages. I thank you.
Thank you. That's all.
Thank you, Tate. I will take the research and technology perspective on this, and the main challenge here is how can we understand when a decision is better taken by a man, and when is the decision better taken by an unmanned platform, in order to increase the overall capability of the mission, because that's what we're all after. And today we are quite mature in areas of basic platform autonomy, to transfer or move a platform from point A to point B with navigation and obstacle avoidance. That's quite mature today. And here we often use mission planning to pre-plan routes and remote control whenever something unexpected happens. But when it comes to tactical autonomy, and that is to autonomously perform a mission in areas where you need to outsmart a potentially hostile opponent, and not just follow the pre-planned routes, is something different. And here there are a lot of challenges remaining. Here we need to know how we can trust the autonomy in an unmanned platform to fully understand the mission objectives. And we also need to understand the limitations to where can we not trust the autonomy anymore. When do we need to support or remote control? And how can we train a system like that to perform in a way that we can predict, understand, and also trust? And here mission planning becomes crucial because if we do a lot of detailed mission planning by the man, we can do that, but how much of the mission planning can be trusted to an unmanned component to do autonomously on the go as response to unexpected events?
Interesting. Well, great comments, and I think a diversity of perspectives on the topic of human-machine teaming. I think it might be useful if we just took a step back now that we've gotten some of these high-level insights about key issues and actually look at the concept of human-machine teaming and ask you all again to comment on the question of, where you see the value going forward. I know where we are today, but what are the areas that militaries are really looking at in terms of employing human-machine teaming for operational advantage? And again, we'll just go down the line. We'll mix it up a little bit later.
So for me, it's the transitioning into the automated world of the machines making more decisions rather than taking the human throughout the whole mission. We heard earlier on that people get tired, but actually it's a really resource-intensive environment operating a remotely piloted air system 24/7. The constant churn of the people is actually a challenge for us in the UK forces to deal with the size and the mass of the squadron that we require. So I think we've got to think about how can we pare that down? How can we work with regulators to gain their acceptance that we don't necessarily need a whole crew to be sat monitoring what's going on all the time? This preconceived idea from the Civil Aviation Authority that you must have a pilot operating the aircraft at all times. We've got to try and break through that and enable the aircraft and the machine to start making its own decisions as it goes into potentially hostile territories and recognizes some threats and can adapt accordingly.
Sure. Great. Thank you.
Yeah. Just to try and always to wear the two hats, so let me say C-level, former C-level, and consultant now. I talked about a new paradigm, so let's bring back to the paradigm. So in the 90s and 20s, basically, the AI, where it started, early age AI, and unmanned technology were a complement to the aircraft. So basically, the aircraft was the main platform driven, and then the systems on top. In the 2000 and on, now basically we talk about the system of systems. So always much more integrated technologies, and basically all the new, for example, fighters and also unmanned basically are driven by system platform is just a complement to it, like Tempest, FCAS programs. So in this respect, by the way, AI and unmanned technologies will bring at a certain stage, for sure, so no doubt about that, that, let me say, last mile capabilities in terms of developing millions of big data in order to allow to the troops on one side, but also on the civilian side, by the way, to elaborate multiple model to real-time decision-making, allowing real fast in hostile scenarios, but also in everyday scenarios. So that's why the change of paradigm is also that no longer boundaries on military and civil exist, because in 2030, basically the use of unmanned technologies for unmanned or advanced air mobilities in the cities will become much more a service used by the civilians, and this will be also the scale effect that has been touched during the panel one, that will allow also much more progress also on a side in terms of cost effectiveness.
The challenge we see to answer to the client worry is that we want to create between the man and the machine the same confidence that the commander-in-chief has in his commanding officer of a ship. And this process takes years for men to build trust between men. And that takes schools and a lot of experience process. And this is a challenge. And that is the first place. And we hope that computer will reduce that time. The other one is the way the commander-in-chief gives its order to his commanding officer. As I was a lead planner for the Atlantic for a French Navy, it took days, even weeks, to build this instruction and to tell the commanding officer how to behave and what is his mission goals and everything. And we have to now make a software, which is the end product, a software that will recreate this trust and these instructions in a way that will be understandable by the commander-in-chief, and now, and in the end, implemented, of course, in the unmanned systems. And when you see, and this interface and this software is a great challenge, because it will build the trust from the commander-in-chief perspective and then translate it into algorithms. And when you see algorithms, you know that it's not friendly at all. Right. And the commander-in-chief wants his idea to be understood. And this is where we focus, because this is the place where the trust will be built.
Right, and speed seems to be the most important, or among the most important qualities that we're talking about here, because you just won't have the time, right? The situation will be moving very fast, especially if your competitors or adversaries are also employing artificial intelligence. So being able to trust something in the instantaneously seems to be a major challenge. Sorry, Peter.
Yeah, I think what we want to achieve really is to increase the overall mission capabilities. And an increased level of man-unmanned teaming with higher levels of autonomy will actually increase the human authority over the whole system, because as they talked about in the previous panel, if you don't need to concern yourself about basic things like takeoff and landing, but can actually, as a man, focus on the mission objectives and let the autonomy manage all these routine things, human authority and mission objectives can be much more of focus. And we all know this, that today with all these sensors, all this information, it's very easy to get overloaded as a human. Let's use the systems to do what they do best and work on that. And that way we can speed up our OODA loops, which means that we will react faster.
Well, Peter, you used, we talked a lot about machines so far. It seems to me that human-machine teaming, there's the machine component and the human component. And as we think about the future of human-machine teaming, and we've already referenced on a couple of occasions, single individual humans operating or managing the inputs and activities of multiple machines, does that change the type of person that militaries, or the type of training that militaries need to do for humans? Do you have to recruit different skill sets? For example, a pilot, where traditionally pilots have been very dexterous physically. Now they have to deal with decision-making processes that perhaps they didn't have to in the past. Do you see that as being a big enabler or potentially hindrance for adoption of human-machine teaming?
I think we're already starting to get there. With the modern types of aircraft, you don't need to do that much of flying. It's more of being a system operator, and I think this will take that even further. Sure.
So, Emmerich, do you think that defense communities and those in the audience here today who are in the defense communities or advising them, do you think what sorts of skill sets do you think are going to be most important for operators and strategic decision makers as well?
The first, the skill sets is changing. You're fully right. And talking from our perspective and working close with the French Navy, we have that close talk with them, and with shaping the future jobs even in Navy, well, we're talking about it's an exchange, and then they gave us direction, and we give them information on future technology. So yes, these are more intellectual skills, and system supervisors having some being able to build in front of the action, but I don't know the term in English, but take some distance from the action to be able to analyze and be less an operator than a commander. That was very accurately said before.
Sure. Cesar?
I think that the skill set will be, I agree with Emery. Basically, it's much more the decision maker based on real-time data that will be significantly higher in numbers and in complexity. So with also systemic view on connecting the dots. And the other one is a kind of soft skill that is a trust in the technologies. I mean, we talked about the technology itself and the unmanned technologies, but we are not underestimate, but maybe is the next point. So the trust that we need to build in the technologies, and so he has to be confident with and understand the general mechanism of how the technologies will make it is easier, is decision loop or decision process.
Okay, great. Commodore Hicks, I'd like for you to address that question as well, but also because you referenced training in your virtual synthetic training environments in your opening comments, maybe offer some insights into how synthetic training may help with this process of bringing humans along and building trust.
Yeah, so I think the UK's started to think really carefully about how do we bring people in from the civilian environment into this world. We started off by using pilots from ex-aircraft, ex-fixed-wing manned aircraft, and bringing them into the remotely piloted world. And then we went to a really pared-down system where they get very few flights on a real aircraft before they, a manned aircraft before they start operating RPAS, a real aircraft. And I think, there'll be operators out there screaming, saying, no, I disagree. But I think the new millennial who has been brought up in this environment, this virtual environment of taking multiple data streams from multiple places are the people that we need to be focusing on. I speak to my children and ask them a question, and the data just comes in to a single device on their phone, and they collate that data really, really quickly, and they'll give me an answer. So I think we should be pushing the boundaries a little bit further. We could take one of those millennials and using, we could immerse them. The simulator systems that certainly we were getting on the MQ-9 Bravo are so good that I believe you can immerse them in that for a period of time and get them up to speed to be able to operate, and stop thinking of them necessarily as pilots, but more as mission commanders. They are decision makers that are there to make decisions as the aircraft does what it does. It takes off itself, it lands itself. The automatic takeoff and landing is a revolutionary step as far as I'm concerned. And we need to then take them into that environment, immerse them, and there are complications when we operate into hostile territories where the air traffic might be complex, and we need some airmanship inculcated into them. But I think we need to think differently about that process of training them and getting them to that point where they operate the aircraft.
Interesting. Very hopefully humorous anecdote. My eldest son the other day asked Alexa what the fastest mile ever run was. So how fast has anyone ever run 1 mile? And the answer was 3 hours, 43 minutes, and 13 seconds, which of course is wrong. It's actually 3 minutes, 43 seconds, and 13 hundredths of a second. But because Alexa's wasn't able to communicate the 3 digits, all it knew, the 3 hours, minutes, and seconds, we got an order of magnitude difference in the correct answer, which of course for us is humorous, but for military operators, even my son, who's only 11, was able to see that answer was wrong. And I think building trust by interacting with machines growing up is probably a helpful place to look for recruitment. But so I want to go back to regulation. Actually, you mentioned, Alex, in your last comments, new ways of doing things. And I know we'll have an excellent panel on adoption and integration challenges. So I don't want to hit too hard on the organizational culture side, except to say that we're asking organizations to do new things when it comes to human-machine teaming, and regulators in particular. How can we convince them that this is safe, trustworthy, reliable, that these are really, the benefits outweigh the risks? And so we'll start with you on this, if that's okay. Yeah.
Well, I can bring and share with you our experience on Italian side, but generally speaking, I think that is quite spread out all over the world. So there's a new model of collaboration among different entities. So starting from the military, obviously, where the technologies normally until the past were born. Now the paradigm is that the technologies are born on the civilian side and mutuating, especially from the space to the military one. But the new way of collaboration among different entities is something that create a kind of reliability and trust on technologies, also from the regulation point of view. On the Italian side, we are experiencing a very good and effective way of working together with the civil national aviation authorities, the military one, and aerospace and defense industries, small medium enterprise and research center in creating what we call the strategical national roadmap for implementing advanced air mobility. That is something lateral, but it's not very far, because at the end the base technologies are the same with a different level of risk. And what we are experiencing is having a much more flexible approach from the regulation point of view that starts in accepting the failure-based approach. So that is, okay, let's make the test, sandbox approach, let's make a test, and then according to the failure, then we can develop or adjust regulation. So regulation is no longer like in the 90s as a roadblock that has to be overcome and to be convinced that they need to adapt, but is part of the mechanism that push the technologies, either developer or adopter, in order to continue and progressing in that direction in terms of then having at the end general services that can be used by the end user, military or civil one.
So can we leverage sort of this, because militaries are regulating probably a little bit faster than the commercial, as pointed out in the last panel. Is there a way to use what the military is doing or the government is doing to add that stability to help push along other regulators outside of?
That's exactly the point.
That's exactly the point. Yeah. So we need to be able to do that. Yeah. So, Amar.
One way we can help regulator to follow or to go along with this movement is to help him think of, because there is only one thing that interests him, is who bears the responsibility if anything happens. Yeah. And in the case of remote piloted systems, we can put the responsibility on the pilot or the organism that pilots. But in case of autonomy, the question is much more tricky, because the responsibility can be from the system maker or the operator. It has to be discussed, and this is where and it's not decided yet, because right now, for instance, for us, we are at the same time the operator and the maker, because we are doing R&D on that topic. But in the end, we will have the regulator will have to decide who bears the responsibility, and helping him will require a lot of discussions in that matter. And as mentioned before, qualification process will be key Explanation of the decision-making process will be key also, and explain what, in this case, the autonomy was not able to adapt.
Yeah, interesting. Peter?
I think there are several aspects to this, and one thing is, of course, that if we want to start to mix unmanned aircraft, for instance, in controlled airspace, I mean, having unmanned aircraft landing on Abu Dhabi airport, for instance, then technically we can do it today. But from a legal perspective and from a responsibility perspective, of course, it's very challenging. Sure. But then there are also other regulations, especially in military applications of this, where it starts to bound on ethics, like international humanitarian law and lethal autonomous weapon systems and so on. And that's also important to understand about this manned-unmanned teaming. What decisions do we need to take are taken by a man and not by the machine? So several aspects here where legislation needs to change, really.
Sure. No, that's a great, the safe development and then ethical employment and safe employment is it's a hard question to avoid, really, when you're talking about any autonomous system, but particularly how they work with human beings. Air Commodore Hicks.
I'd probably make 2 points. One, to be frank, I think there's a generational issue. Yeah. I think we have certain people in certain positions within the CAA and the MAA that quite frankly need to move on and allow for the environment to evolve. Yeah. I think the second point is, as we established the Defence Safety Authority, and I know UAE is going through this at the moment, the pendulum of safety, for me, has swung far too far to the right. And therefore, to progress anything rapidly requires the infinite level of detail in everything that we do. And I think we've got to realize that that's not possible. We have to evolve rapidly and quickly with these capabilities. And as our adversaries are able to evolve really quickly, we can no longer afford to take 5 years to certify a capability. So we've got to adapt quickly, and our regulators have got to recognize that that is a problem that we've got to face.
Yeah, which seems intuitive, right? That it's moving at the speed of relevance, but I don't know if you'd agree that defense organizations tend to be somewhat risk averse, or maybe that's an understatement.
Yes.
So introducing risk seems like, or accepting risk seems like one area where defense communities can begin, and security communities as well, and government entities can begin to think a little bit differently about how they do that. I'm also intrigued by the concept of scale, because it's come up a couple of times here, right? Where we're talking about a human operator engaging with 5 or 6, as you mentioned earlier, or maybe even over time, many more times than that. One data point, just last month in the United States, DARPA ran an experiment in which one human operator was able to control 130, I believe, small drones. Now, it's not ready for fielding, but it's an interesting data point. How do we see these concepts, these big concepts of individual humans managing the activities of not just 3 or 4, but 30 or 40 or more? Does that change the dynamic? Does it change the challenge? Does it make it bigger, or is it just the same challenge and we just, same problems? And Emmerich, if I could maybe start with you on that one and then come down.
Well, the fact is that for, I would say, unfortunately, for a commercial point of view, that we don't foresee very soon once a Navy officer controlling hundreds of drones, right. Especially because maritime systems are quite big. Sure. So it will be just, well, as we foreseen, middle term, just maybe 1/10 of it, which is a pretty amount because anyway, all the tasks to be fulfilled when you take the crew out will still the same. So, but the way we see it is first working on the reliability of the systems, because you must evacuate as much as possible technical failure, and this is the first point we're working on. Next is the operator or the controller or commander, more likely being overwhelmed by the situation itself. And so how can we help him to cope with that without having to worry about how to control and command the drones, but that's the next step.
Interesting. Peter.
I think, especially regarding logistics, I think scale is going the wrong way today. If it takes 10 people to launch a UAV from a ship, for instance, then we're not achieving the kind of scale we want. I think that one response to that is what was discussed previously with swarms.
Right.
How can we actually use swarms so that, from that perspective, it's considered as one unmanned system, but in the swarm itself is a system of systems. So that we don't need to interact with each and every one, but can actually interact with the swarm as a system. I think that's one way of achieving this scale.
And to Amarik's point, I mean, how close, into the, actually stealing the question from the last panel, how close are we to those kinds of scales, both in the air domain and in the maritime domain as well, Amarik?
Well, in maritime domain, we'll see first application within 5 years, I guess, especially for underwater systems, because of the challenge it is of the environments. And we hope to be fully operational with system within 10 years, like it was said before. Yeah.
Peter.
From a technical point of view, I think it's also 3 to 5 years perhaps, but then to actually have it making sense from an operational point of view, we also need to understand our customers' ability to use or deploy such a system. So I think there, the interaction with the end user is extremely important, because we cannot rely only on technology push, but also the customer must have a way to utilize the capabilities.
So on scale, what are your thoughts?
Yeah, I mean, if we focused on military side, I agree with Peter. I mean, the swarm by itself, by definition, is the real step change that will allow the scale effect, but with no intervention from the human. This is my personal view. I mean, at that time, the technologies should be that human is kind of a supervisor rather than in command. So supervisor, the activities and the real-time correct functioning of the swarm itself. But the swarm is how to adjusting ecosystem, let me say. Okay. If we switch on the civilian side, I mean, I think that the scale effect may be not just in the number of the unmanned system to be operated, but also in the number of operations that simultaneously will be allowed. And on that side, I think that, I mean, we are almost there already. I mean, Paris 2024 will adopt a kind of aerial mobility for the Olympic Games. On the Italian side, we also, so I make a spoiler, we will use Milano Cortina Winter Olympic Games to use in significant services from logistic point of view in supporting this Olympic edition that is the first diffused one among 2 different locations and the regions. So I think it's matter really of 3 to 5 years, and maybe in 10 years we will have both military and civil side that will have reached, let me say, sufficient maturity of levels to be scaled, the technologies.
Air Commodore Hicks, any thoughts on scale, either at 5 or 6, which you said I know is a step change in some ways for the regulators?
So I think the term RPAS covers such a huge field, which makes this complicated. If we're talking about swarming drones or small tactical, then the mass of 100 being operated by a single individual, I see as entirely feasible. And I probably see it before 3 to 5 years, probably 2 to 3 years. I think that's possible. I think when you go to the strategic, medium altitude level, long endurance aircraft, I think 5 or 6 operating over a maritime domain where you're looking at a huge area, using AI to provide automatic detection and highlight problems. I see that's absolutely where we should be going. I think over land right now, that's probably not something we're going to see in the next 3 to 5 years. So 3 to 5 for me sees multiple aircraft being operated in the maritime domain. It's probably 10 years plus before we see that over land.
So we've got about 3.5 minutes left before the panel concludes. So what I'd like to do is just offer each of our panelists an opportunity to, just one or two final takeaways, things that came up in the panel or just points that you made earlier that you'd like to reinforce if you were advising industry or defense communities on next steps or things to really pay attention to when it comes to human-machine teaming. What would you say? And we'll just go from down the line.
Wow, that's a big question.
It is, but you have 40 seconds to answer.
40 seconds to answer.
No pressure.
So, training, transformation, automation, and integration with regulators to make the world move more quickly.
On my side, I would say a new way of collaborating among the military and civil side. AI that will become much more important in adopting unmanned technologies. And just as a final provocation, but maybe it's not. Yesterday I was joking with the colleagues of mine that is here, and we were discussing if it's not the case to think about unmanned technologies as the future general commodity.
Interesting, General. Very interesting. Amr.
Well, what we're working on is taking principles and recognized and manners, like for the trust will be built by implementing the same process that we used to know, for instance, giving the mission by setting goals, behavior rules, and limits. For aircraft pilots is prioritizing the path, then the platform, then the mission, and the challenge is to translate that into algorithms, and that's what we tend to do.
Great. Tata.
Yeah, I think the key here, as we discussed before, is trust. Trust is something that needs to be earned. And how we can do that, we talked a bit about this with explainable AI and knowing that things are predicted, so that you can predict things. And also, I think, understanding how we can train these systems. It was discussed in the previous panel, training with historical data. I think what will be very relevant in the future is to train in a simulated digital twin kind of environment where you can actually start to create the new data as you go. I think that will really be the future for this.
Yeah, and then thanks that's a great point that I had hoped to get to today, and I'm glad we got to it even at the very end. The digital engineering and digital simulations, being able to massively expand the scenarios in which these systems are trained against seems like a real force multiplier and enabler. So with that, we're actually going to finish, believe it or not, right on time, which I think is an accomplishment that I'm not sure I've ever had as a moderator. So congratulations to our panel for being both so brilliant and insightful, but also succinct. So thank you very much, everyone. This has been, I think, a really interesting panel on one of the most important areas of the future of autonomy and uncrewed systems. Thanks so much.
Thank you.